Most waves need something to travel through, like air or water. But puzzling to some scientists as far back as 400 years ago is just how light can travel through space when there is nothing to travel through. Let's think of a wave as being like a transfer of energy from one place to another. Seawater waves result from wind moving over the surface of the sea, creating at first small capillary waves, tiny waves which are completely unsuitable for surfing. As strong winds continue to move over the surface of the tiny waves, more and more energy is transferred and the waves grow in amplitude. Some waves grow extremely big. Currently the world record for surfing big waves is about 25 metres. But every single wave starts out as a tiny capillary wave first, even the huge ones. Think of it like rolling a snowball down a hill that just grows and grows and grows, and as it rolls on it collects more snow. Once the snowball stops moving, it stops growing. Once the wind stops, the waves die down eventually. Without the water, the wind would just be moving columns of air. And without the air, well, obviously no wind. Simple. So what about light? Light is another way of transferring energy from one place to another, just like other waves. A source has to produce that light. Let's say, for example, a big hot ball of gas, like our sun. No sun, no source of energy, no light waves. But just like sound waves and water waves had to travel through something, famous scientists in the past postulated that light must have a medium to travel through as well. Some early scientists called this medium the ether. The theory of the ether was born around 400 years ago, so it was a theoretical medium in which light could travel. The use of the ether to describe the motion of light was popular during the 17th and 18th centuries. But not just light, Albert Einstein also used the ether concept to describe gravitational fields. Scientists for hundreds of years have been trying to comprehend the gravitational field, electromagnetic field, including light, into one unified theory, and they've yet to do that even today. Back to Einstein. He stated that space without the ether is unthinkable, as not only would there be no propagation of light, but also no possibility for the existence of standards of space and time. Because the speed of light is so huge, and because material bodies pass through the ether without obvious friction or drag, the ether was assumed to have a highly unusual combination of properties. It was thought to be an omnipresent, perfectly elastic medium having zero density. Can you imagine trying to design an experiment to find that? Obviously not easy. But designing such experiments to investigate these properties was a high priority of 19th century physics. And one such experiment was designed to detect something called the ether wind. So as the Earth and the ether were thought to be in relative motion since the Earth moves through space, it implied that a so-called ether wind should exist and would exhibit a drag effect on anything that moves through it, including light, which would alter its speed in different directions, as light would experience drag. To imagine this, try to picture yourself swimming through a stream, side on to the current, and then in line with the current, your speed would be different. It'd be harder to swim against the current or perpendicular to it. So scientists thought that by analysing the return speed of light in different directions at different times, the speed of light that they measured should also be different. And if they measured these speeds of light and they were different, this would confirm the ether wind, and in turn would confirm the existence of the ether. In 1887, the Michelson-Morley experiment was designed, but it concluded that light speed was a constant. There was a small velocity difference measured between light that travelled perpendicular to each other, but it was considered at the time far too small to be used as evidence of speed relative to the ether. It was dubbed the most famous failed experiment in history. If you like, you can Google that and you'll find it. Actually, I think I used Bing. This experiment gave way to fundamental conclusions in physics. One of those was Einstein's theory of special relativity, which stated the speed of light in space is the same regardless of the motion of the light source or the observer. And due to the high-profile nature of the experiment carried out by Michelson-Morley, scientists were very reluctant to even use the word ether for a long time. So was that the death of the ether? Well, in order to explain the consistency of the speed of light, 10 years later Einstein talked about combining space and time into a single framework, and both space and time would conspire to keep light the same speed for all observers. But note, space-time isn't an actual thing, it's just a concept, just like the ether was a concept. And for now, space-time is just an evolved theory, not all that different to the ether. And one day, will Einstein's theory be seen as flawed eventually? Some will tell you that flaws are already being exposed in his theory. But for now, it's one perfectly adequate theory of gravitation.